This video is a collection of food factory explainers. It shows how everyday food is made on industrial production lines. Why is KFC chicken so cheap? Are they using bad meat? No. The real reason is hidden inside the food processing system. From the moment a chick hatches, it takes about 40 days before it becomes food on your plate. That's because these chickens are bred specifically for industrial food production. Fast growth, high efficiency. Once they enter the factory, they don't instantly turn into fried chicken. The first step is standardized cutting. Machines slice everything to fixed sizes. Drumsticks, wings, breast meat. Each piece is separated and portioned to nearly the same weight. And the leftovers? Nothing gets thrown away. Small pieces and trimmings from the breast are ground and reshaped, pressed into uniform portions. Those go to secondary product lines, chicken nuggets, patties, even diced chicken used on pizzas. The final steps are coating, pre-frying, and flash freezing. Everything is moved through a cold chain system and shipped to restaurants. The actual deep frying only happens after you place your order. So the reason it's cheap is simple. Mass scale, strict processes, and almost zero waste. Not bad meat, just a highly optimized industrial system. That's why it's inexpensive. Not because the chicken is low quality, but because every single step has been calculated down to the smallest detail. Why are more people choosing frozen pizza? Is it because it's cheaper? Not really. The real reason is this. It can actually be healthier than pizza from a shop. Inside the factory, large industrial mixers run at high speed. The dough is kneaded again and again until the gluten structure becomes stable. After fermentation, the dough is cut into perfectly uniform round pizza bases. Those bases go straight on to the assembly line. The sauce isn't spread by hand. It's applied by metering pumps, same thickness, same coverage, every single pizza. Then cheese is evenly distributed by automated spreaders. Pre-cooked sausage is sliced to a standard thickness, then evenly scattered across the pizza so you don't end up with one that barely has any toppings. Next, the entire pizza enters a flash freezing tunnel. The temperature drops below freezing fast, locking in the structure and condition. After freezing, the pizza moves into an automated packaging line, sealed, weighed, and labeled. Then it enters the cold chain system and gets shipped to grocery stores nationwide. So here's the real question. When a pizza's journey from ingredients to finished product is clearly defined at every step, are you really sure the pizza from a shop with a back kitchen you never see is always the better choice? Chinese people are crazy. They packed an entire pot of soup into a tiny packet. And this packet? It's not meant to drink. It's meant for cooking. So how do they do it? It starts with fresh tomatoes. Ripe tomatoes are harvested and shipped straight to the factory. The first step isn't making soup. It's breaking everything down. The tomatoes are poured into hot water, using heat to loosen the skins naturally. Then comes a rough mix. Workers peel the skins off by hand, one by one. The peeled tomatoes go into an industrial blender and are turned into smooth tomato puree, then set aside. On another line, cooking oil is heated in a large pot. Fresh ginger is added for aroma. Once the flavor is released, the ginger is removed, leaving ginger-infused oil. Next, onions and more ginger are added and slowly cooked to build the base flavor. Then the tomato juice and prepared tomato puree are poured in together. About 1 ounce of sugar and salt are added, carefully measured. The mixture is gently simmered, as excess water cooks off and the flavor concentrates. Once finished, the soup base is packaged and shipped nationwide. That's how 1 packet of concentrated tomato soup base is made. At home, just add water and heat, and an entire pot of tomato soup comes back to life. You might think this is medicine, but in Korea, this is an actual meal. They've taken an entire bowl of soup and compressed it into a tiny pellet you can keep in your pocket. Just add hot water, wait a few seconds, and it turns back into a steaming bowl of soup. This is one of Korea's large soup pellet factories. Fish heads are packed into filter bags and cooked in a pressure cooker for about 2 hours, slowly extracting a rich, concentrated broth. Once it cools down, the broth is poured into molds and sent into a freezer to solidify quickly. At the same time, vegetables like cabbage, mushrooms, and lotus root go into ultrasonic washing tanks. Tiny bubbles vibrate through the water, knocking off dirt and impurities without damaging the food. After washing, peeling, and slicing, the vegetables are frozen at around -35°F, then moved into a vacuum chamber. The ice turns directly into vapor, removing water while locking in flavor and nutrients. The dried vegetables are then ground into an ultrafine powder and mixed with fish broth powder made using the same process. The mixture is compressed into shape, forming these soup pellets. They may look small, but 1 pellet holds the essence of an entire bowl of soup. Unlike ready-to-eat meals that are just reheated, this is about concentration, portability, and restoring fresh flavor on demand. Today, these soup pellets are carried by office workers, students, and even soldiers as pocket-sized energy soup. Why are they pouring what looks like concrete over eggs? Is this some kind of fake egg scam? No, it's actually there to protect them. This is a real egg grading factory, and it processes tens of thousands of eggs every hour. As the eggs move along the conveyor belt, they pass through a candling system. A bright light shines through each shell so machines can see what's happening inside. Some eggs look perfect on the outside, but still get rejected. That's because the air pocket inside is too big. The longer an egg sits, the more moisture slowly escapes through the shell, and the more air gets trapped inside. That's how the machine knows whether an egg is still fresh. The eggs that get rejected don't go to waste. They're cracked open, pasteurized, and turned into liquid egg that gets sold to cake factories, bakeries, and mayo makers. So the cookies, cakes, and salad dressings you eat often come from eggs that weren't good enough for the grocery store. In the end, the eggs that pass every test are gently placed into cartons, sealed, stamped with a date, and sent straight to the supermarket. This is something most Americans are afraid to eat, but in Japan, more than 20,000 of them are processed every single day. These octopuses are taken out of frozen storage and dumped into water to start thawing. Once they're thawed, they move onto a conveyor belt. Workers rinse them with water because when the ice melts, it releases a strong, fishy smell. If it isn't washed off here, that smell gets locked into the meat during cooking. Next, the beak and the organs are removed. If those parts stay inside, the meat turns bitter. After that, the octopus is dumped into a large tank. Workers pour in coarse salt and keep stirring. The salt pulls out the slippery slime from the surface. Then the octopus is sent into hot water. It's boiled for just a few minutes. The outer layer tightens up, locking the moisture inside. That's also when the color turns bright red. Next, it goes into cold water. This makes the meat firmer and stops it from cooking any further. After cooling, the octopus goes back onto the conveyor belt. A machine checks it for any foreign objects. Finally, it's weighed, packed into boxes, topped with ice, sealed, and sent to market. So, would you dare to eat this kind of octopus? Donuts are the only kind of bread that get deep fried, but they don't taste greasy. In a factory, the dough is pressed into perfectly even rings. Every one is the same thickness. Those rings ride a conveyor straight into hot oil at about 350 degrees Fahrenheit. The moment the heat hits, the water inside the dough flashes into steam. That steam pushes outward, creating a pressure barrier that keeps most of the oil from getting in. So the donut cooks fast, but it doesn't soak up much oil. On the production line, the donuts keep moving. They flip, float forward, and pass through a draining section. Extra oil drips off and flows back into the fryer. Then machines move them to the next stage. Some donuts get dipped into warm glaze. Others get coated with sugar or topped with chocolate and chopped nuts. Every layer is carefully controlled so the soft shell doesn't collapse. Once the surface sets, the donuts line up neatly and head straight into packaging. What you end up with is a donut that looks fried, but feels dry on the outside and soft on the inside. So here's the real question. Was it actually cooked by oil, or was it cooked by steam? Have you ever eaten a first-class meal on a plane? This isn't food that's just heated up in the air. It's part of an industrial process where mistakes aren't allowed. Eggs are pumped through pipes straight into flat-top pans. 2 seconds later, perfectly cooked omelets slide out and stack up in neat rows. Once the hot dishes and sides are finished, workers carefully label every tray. Flight number, cabin class, meal type, nothing can be wrong. Those trays go straight onto a conveyor belt and into a blast freezer, where the temperature drops fast, basically freezing time. After chilling, the meals move to the other side of the facility. A different team starts assembling full meal sets. Main dish, sides, dessert, each one matched precisely. Then everything is wrapped tightly in aluminum foil. At the same time, another line of workers prepares trays and utensils based on the number of passengers on each flight. The assembled meals are placed onto the trays and loaded into service carts. About an hour before takeoff, those carts move through a dedicated corridor and go straight onto the aircraft. For first class, the process isn't over yet. A chef on board finishes the final cooking steps in the pressurized cabin. So now I'm curious, what's the best airplane meal you've ever had, and which airline was it on? What we eat today as peanut butter wasn't originally meant to be a snack. It started as a medical invention, to provide protein for people who couldn't chew meat. The idea was simple: turn peanuts into nutrition you don't need to chew. The best peanuts for peanut butter are called runner peanuts. Their uniform size helps them roast evenly. By the time they reach the factory, they've already been shelled. One 18-ounce jar of peanut butter takes about 20 ounces of peanuts, roughly 1,100 peanuts. They're roasted in hot air at about 400 degrees Fahrenheit, constantly shaken so every peanut cooks evenly. After roasting, they're cooled quickly to stop the process and keep the oil from escaping. Next, the skins and peanut germ are removed because they add bitterness. Nothing is wasted. The skins go to livestock feed, and the germ is used for bird feed. Finally, the peanuts are ground into a smooth paste. Small amounts of salt, sugar, and stabilizer may be added to prevent oil separation. Peanut butter has no preservatives, yet it can stay shelf-stable for up to a year. It's rich in unsaturated fats, and that's why peanut butter looks intense during processing, but is actually one of the simplest foods at its core. Have you ever thought about this? A single bottle of orange juice takes more than a dozen oranges to make, yet it sells for just $2. That price can't even buy 10 oranges at the store. So here's the real question. How does the factory make money? Or is there something added that you don't know about? The truth isn't what most people expect. First, the oranges factories use aren't the ones you buy. They're not sold by the piece. They're sold by the ton. Too small, too ugly, spotted on the outside but not spoiled. In a supermarket, they're worthless. In a factory, they're just raw material. After the oranges are juiced, the juice isn't bottled right away. It's deoxygenated, cooled, and stored in massive tanks. The flavor is separated. The liquid is preserved. When it's time to sell, everything is recombined, not artificial flavor. The orange's own flavor is added back. Legally, it can still be labeled 100% orange juice, so orange juice isn't cheap because oranges are cheap. It's cheap because the entire production system has pushed the cost to the absolute limit. This is the real difference between schools in Japan and the US, and it's not just about one meal. Today's main dish is teriyaki yellowtail. All ingredients enter the kitchen through a special docking area. Only one door opens at a time to keep dust and outside contaminants out. The sanitation standards are extremely strict. Once the vegetables arrive, they're washed, cut, and peeled. About 40 workers handle everything by hand. All the produce comes from local farmers, with one goal in mind, making sure kids eat fresh, seasonal food. The miso soup starts from scratch. The stock is made with kombu and bonito flakes, then blended with both white and red miso to create a deeper, richer flavor. The fish is marinated by hand, then sent into massive ovens, each one capable of cooking up to 100 pieces at a time. Only after everything is ready does it all come together for the final cook. Honestly, there's more food in that pot than I eat in an entire week. This whole system is supported by the government. Public school lunch fees average about $33 to $38 a month, roughly $1.50 per school day. No matter a family's income, every child gets a hot, healthy meal at school every single day. A single pineapple can come out of a factory priced 10 times higher than before. Did the factory make it sweeter? Of course not. What they actually do is something very basic. Before workers even enter the processing area, they wash their hands, sanitize, and change into clean uniforms. That's to reduce the risk of contamination once the fruit is cut open. Freshly harvested pineapples are brought into the facility in bulk. They're washed, lined up, and sent onto a conveyor belt that feeds directly into the cutting machines. The first step is peeling. It's not delicate. Speed matters more than precision. More than 30% of the fruit is removed at this stage. Only the portions with the most stable sweetness and fiber structure are kept. Added, the removed parts aren't wasted. Peels and trimmings are collected, then redirected for juice production, enzyme extraction, or used as animal feed. Next, workers along the conveyor perform secondary trimming, removing uneven edges and inconsistent sections. All remaining fruit is cut into uniform shapes, not for appearance, but so each package has consistent weight, making pricing and packing predictable. Finally, the pineapple pieces are quickly portioned, sealed, and sent into the cold chain. The fruit itself hasn't become sweeter. Nothing about the pineapple has changed. What changed is how its value was calculated. Why do U.S. hospitals and schools rely so heavily on frozen vegetables? Because in many cases, frozen vegetables are more nutritious than fresh ones. After harvest, vegetables for freezing are rushed straight to a processing plant. High-pressure water washes off dirt and residue. Then machines cut them into the right sizes with almost no human hands touching them. Next comes a quick hot water blanching. This kills bacteria, shuts down enzymes that destroy vitamins, and helps lock in nutrients. Then they're flash frozen. Cold air and liquid nitrogen drop the temperature to below -300 degrees Fahrenheit, freezing the vegetables at peak freshness with their nutrients locked in. After that, everything moves to automated packaging. The bags are sealed, labeled, and loaded into refrigerated trucks for delivery across the country. From field to freezer, this can take less than 4 hours. Fresh vegetables are different. Many are picked early to look good on shelves, then stored and shipped for days. They may look fresh, but nutritionally, they're slowly aging. Frozen vegetables are locked in when they're fully ripe.